Greetings. It's time for another Glassboard video for the assembler class. And this is related to Lab 2. I think I gave you Lab 0 and I skipped Lab 1. And in Lab 2, you're going to have this situation to start with where you're going to get a hex digit typed in. This hex digit is going to be an encryption key. So, not worrying about the encryption key right now, we're going to consider the question of when you get a hex digit, how can you deal with it? So the issue is what people type is ASCII. What you're going to need is a number in binary for exclusive ORing. So, for example, if a person were to type a 5, you would get in a register or in memory in ASCII 5, and ASCII 5 in hex would be 35. In binary, that will be 0011100101. Okay? And in decimal, it's what? It's 53. So all of these are the same. The person typed a 5. This is what you got in a register. You got numerically the number 53. You got that same number as a binary, those bits. You got, if you think about it, as hex like that. And if you think about it as a character transferred either in reading or out printing, it's an ASCII 5. What do you actually want? Well, the person was trying to communicate that you should use the number 5. Not the number 53. Got it? They typed character 5, meaning to tell you, the program, that you should numerically be using 5. So how is this going to work? Well, you can actually, since the ASCII numbers are all in the range hex 30, 31, 39, and that's a 0, 1, 9. This is 48, 49, okay, 57. Got it? So when they type ASCII 0, they're giving you decimal 48 or hex 30, and what you want is numerically a 0. So you could subtract, if you subtract an ASCII 0, which is to say 48 from all of these, okay? All right, if you subtract a ASCII 0 from that, and I mean it, you subtract the character 0. The character ASCII 0 is numerically what? 48, right? So when I say minus 0 like that, when I say, we're off the side there, okay? But if I say the character 9 minus the character 0, what I'm really doing is, numerically, that was what? 57 minus 48, 9. Got it? Okay. So that's what you need to do. And we're also going to deal with hex digits, A through F. But that's the same story, but it's different input. Okay. So that's fundamentally what you need to do. So the person typed a character. And it turns out the hard part is not what I just described. The hard part is making sure that we can do a compound if statement in assembler. So I'm going to erase this part because you know it now and it was easy. And I'm going to go look at this part, which is what the code looks like. So in your lab, you'll discover near the top of the code, you'll discover get char and then into DL. So this is the first character in the user's input. It should be a hex digit, which is to say 0 to 9 or A through F. And then what you're going to want to do is the following. If you were working in a regular programming language, you'd say if DL's our register, right? That's our temporary variables. If DL is greater than or equal to an ASCII 0, you could put, hex 30, or you could put decimal 48, it's the same thing. If DL is greater than or equal to 48, or hex 0, okay, and DL is less than or equal to an ASCII 9, then whatever that number that is, then we want to do this computation. Otherwise, we want to do this computation if it's between a letter A and a letter F. And it's going to be a little bit more complicated because if it's not in this range, and it's not in this range, we're going to want to print an error message. So it's like else if and then else error. All right? So that's what we need to do. And the problem is that we don't have if statements in assembler. So what we have is what? We have arithmetic statements and similar things that manipulate the numbers or the bits in registers. And we have jump statements. And we're going to build if statements out of these little bits. That's the idea. So every time you do an arithmetic statement, it leaves the status of what happened in something called the flags register. So every time in the first lab, we noticed we had a loop which was consisted of decrement ECX and then jump if non-zero. So the decrement ECX would leave a result in the flags register as to whether or not that subtracting 1 produced a 0 result or not. And then the jump looked at the status, looked at the flags, and if the decrement instruction left a status hanging around of non-zero, then it would jump. Okay? So that's the little bits and pieces that we're going to build an if statement out of. But actually we have a compound if over here. And we also are not really doing any arithmetic. So we have this and we're comparing it to a 0. You could do arithmetic. You could subtract 0 from DL. That would work. Okay? But assembler actually gives you a nice instruction called CMP. And what CMP does is it pretends to subtract without actually subtracting, throws the result away. It subtracts and it throws the result away. So, and that's a compare instruction. So let's put one up here, okay? So this was what? This was all commenting, right? This was comments. That makes an assembler. We're going to start out with CMP DL, comma, okay? So that's my assembler. This was that part over here, right? Now what are we going to do? Well, I can tell you actually that we can right now do a shortcut. Because if we look at the ASCII character chart, any character that's less than character 0 is off the chart. It's not going to be a hex thing. Because it's going to be between 0 and 9, or it's got to be between A and F. And these are below, these are lower numbers. If it's less than a 0, we need to go out. So what you're going to do is you'll jump, okay? Jump if less than. JLT. JLT, okay? And there's going to be, down at the bottom of the program, there's going to be a label called error. Print message. Okay? So you've already taken care of sort of the biggest else over here by just doing that. So if we compare DL to 0, it's too small, go all the way down. Okay? Now the next comparison is this one, right? And now you're going to notice something that is the way assembler if instructions work is that we always do the logic backwards. The usual form of an if is what? If, then, okay? What we actually do in assembler is comp jump if not true down to okay. So let's call that L10. And then the then part over here here's the else part. Remember, we have to build these if statements out of little tiny parts. And the normal way of doing that is do your comparison and jump the not true, the opposite of the condition. If the if is false, jump down to the else part. Jump down to the else part. If it's false, jump down to the else part. Fall through on the then part. When you get done with the then part, go down here, which is at the end after the if. Got it? Okay. So we did a compare with an ASCII 0. And jump if less than. That's the opposite of greater than or equal, right? So if it's the opposite of greater than or equal, jump out. And in this case, we know it's actually, we're going to jump all the way down to the error. Okay. So that's part of it, but we have another part over here, right? Comp DL 9. Okay. We want less than or equal to 9, right? So we're going to jump if greater. Okay, and let's go down to L10. Okay, let's get rid of this if here, else here for a moment. Or no, we can leave it here, I suppose. Okay, we now get to the then part. And the then part is going to do what? Well, we need to subtract 0. Okay, so we're going to subtract that decimal 48, that hex 30, that character 0 from DL, and then we'll jump. Or something like that. So there's the then part. So we've taken care of the if-then. Okay, here's the if, here's the then part. Okay. Now the else part's going to be another whole if thing, right? So the else parts here was L10. This is another comment, L10. And what are we going to do? We're going to have another comparison, comp DL, comma, an ASCII A, like that. Got it? Okay. If it's less than an ASCII A, because we're looking for greater than or equal to, right? If it's less than an ASCII A, then it's got to be an error, because it was not in this range. It's not in this range, it'll be an error, right? And similarly, okay? So that's JLT, J less than, you jump if less than, comp, DL, comma, ASCII F, J greater than, and then over at the bottom here, we're going to convert it. Here's the then. Okay? So here's the then part of this if. And what we'll do is we'll take that. So this is what? This is some character. It turns out to be what? It turns out to be hex an A. Okay. Let's go over here. If we got a letter A, that's a hex 6 alpha. This is 6A, 6B, okay, all the way up through 6-1. All the way up through 6-6, okay, and so what's that? That's 97, right? This hex. 97, 98, okay? All the way up through 102. Numerically, what do we want? Okay? Numerically, we want, okay, this should be what? A should be 10. 11, all the way up through 15, right? So we're going to have to subtract something, right? So I want to subtract 87. So if I subtract numerically 87 from my ASCII A, I'll get 10, which is the number that the person typed in A. What they're meaning to tell us is the number 10, right? Okay, so that's what happens down here in the then part. Got it? So instead of subtracting an ASCII 0, which is to say decimal 48, we can subtract a decimal 47, right? Or decimal 87. Okay, so I have another video which I'll put up, which largely duplicates this from last year, which is called Compound Ifs. But this one is especially tailored to Lab 2. Thank you.